This is Mrs. Benke, and these notes are on ionic bonding. In this section, we're going to be looking at cations and anions and determining how they transfer electrons to form compounds. All right, so just to review from our previous notes that cations are going to lose all of their valence electrons. So if they have 3 electrons in their outer shell, they want to get rid of those 3 electrons. Okay, so however many they have in their outer shell, they want to get rid of. Anions want to gain enough electrons to have a total of 8. So if they have 6 electrons in their outer shell, they're going to want to gain 2 more to end up with a total of 8. And what we're going to do is we're going to have one cation and one anion that make up the ionic bond. And we're going to show the movement of electrons away from the cation and towards the anion using arrows. All right, so we draw our Lewis dot diagrams like we did yesterday, and then we show the transfer of electrons from the cation to the anion. For our first example, we're going to be combining sodium and chlorine. Sodium is Na, and it has 1 valence electron. Chlorine is Cl, and it has 7 valence electrons. So sodium wants to get rid of its 1 valence electron, and chlorine wants to add an additional valence electron. So we show this movement of electrons using arrows. So we're going to draw an arrow showing that the 1 electron from sodium transfers over to the chlorine. Okay, and that gives us the formula NaCl. We know that we're done because we've gotten rid of all of the electrons around sodium. And if we count the electrons around chlorine, we now have 8 total electrons around the chlorine. For the second example, we have magnesium combining with oxygen. So magnesium is Mg, and it has 2 valence electrons. Oxygen is O, and it has 6 valence electrons. All right, so the magnesium wants to get rid of its 2. Oxygen wants to gain 2, and those 2 empty spaces. So we're going to show the movement of electrons by drawing our arrows. So 1 electron moves over here. The second electron moves over here. All right, so we've been able to get rid of both of magnesium's electrons. Oxygen now has 8, okay, because we have the 1 that moved for magnesium there and the second one that moved for magnesium right there. So when we write our formula, we have MgO, because if we look up here, we had 1 magnesium and 1 oxygen. All right, for our last example, we're using magnesium again, but now we're also using nitrogen. So from our last example, magnesium is Mg and has 2 valence electrons. Nitrogen is N, and it's going to have 5 valence electrons. Okay, so magnesium wants to get rid of its 2, and it's going to do that by transferring them over to the nitrogen. My problem with this is that nitrogen now has 7 valence electrons rather than 8. So we have 2, 4, 6, and 7. It has to have 8. So if I'm going to add more electrons to the nitrogen, I'm going to have to add another magnesium. So I can only add what I already started with. Okay, that magnesium also has 2 valence electrons, and I'm going to transfer 1 of them over to my nitrogen. That's great for the nitrogen because now it has 8 valence electrons. But my problem is this magnesium still has this 1 valence electron that it hasn't been able to get rid of, and we need to get rid of that. So to do that, I'm going to add another nitrogen. Okay, and I'm going to keep going back and forth until all of my nitrogens have 8 and all of my magnesiums have nothing left. So this lets me transfer 1 electron from my magnesium, which gets rid of the 2 in my magnesium, but it leaves me 2 more spaces in my nitrogen where I need more electrons. So now I go back one more time. I'm going to add my 3rd magnesium. I'm going to transfer those electrons over to my nitrogen. And now I know I'm done because all 3 of my magnesiums have gotten rid of all of their valence electrons, and both of my nitrogens have a total of 8 valence electrons. Okay, so now I know that I'm done. I'm going to write my formula, and I'm going to count. I have 3 magnesiums. So when I write my formula, I'm going to write Mg3. And I have 2 nitrogens. So again, when I write the rest of my formula, I'm going to write N2. So my final formula is Mg3N2. All All right, so on the final slide here, I want you guys to do these 3 practice problems. Draw the Lewis dot diagrams for the elements listed, and then show the transfer of electrons using arrows. So you're going to be combining calcium and phosphorus, sodium and bromine, and barium and chlorine.